Welcome to episode 150 of the Microsoft Cloud IT Pro podcast, recorded live November 4th, 2019. This is a show about Office 365 and Azure from the perspective of IT pros and end users, where we discuss a topic or recent news and how it relates to you. This week, we have an interview live from Microsoft Ignite. Ben had the opportunity to sit down with Julie Love, Senior Director of Quantum Computing at Microsoft, to talk about quantum computing and Azure Quantum. All right, so this is Ben. Scott has off doing other stuff. We're at Ignite, but I am sitting down with Julie Love, and you are a Senior Director at Microsoft in the quantum space. So this is something we have not covered on the podcast at all. So do you want to give us a little introduction about who you are, what your role at Microsoft is, how you even got involved in quantum? Because it's also kind of a fairly, I feel like it's been in discussion a lot, but a fairly new field compared to some of the other technologies. So do you want to give us a little introduction about you and how you got to where you are today?
Yeah, so I lead Microsoft's business development efforts in the quantum group.
Okay.
So I spend a lot of my time out talking to customers and bringing a deep understanding of what quantum computers can do and help organizations understand, how quantum can transform their business in the way that they work. This area is a deep personal passion area for me. I have a PhD in quantum physics, in quantum computing.
Oh, wow.
From the team at Yale that invented the superconducting qubit that some of our competitors use. So I wrapped up my PhD, and I've had since then a variety of business and operational roles. I started out at McKinsey doing work in semiconductor manufacturing. I came to Microsoft and had a variety of roles across most divisions at Microsoft. And I spent a year at Adobe running strategy for their creative business. And it was pretty much my dream come true. And to come back to Microsoft and go back into quantum full time. Along that path, I'd been advising quantum startups. And so I'd been an advisor to two and sat on the board of one of them. It's been really fun to see where this field has gotten to and be able to be back doing quantum full time.
Yeah, very cool. So for those of you listening, Julie is way smarter than either I or Scott are and ever will be. It'll be fun. I'm looking forward to this because, again, it's not something we've talked about a lot, not something I have a lot of experience in. So I'm just as much for all the listeners as well as myself curious about it. So from a high level, I kind of have in my head what quantum is, but how would you describe quantum to somebody that's brand new to it or hasn't heard of it before? What exactly is quantum when it comes to the computing and what Microsoft is doing with it?
Yeah, so quantum computing, we're building new types of compute systems that harness the powers of quantum physics. So in classical computers, we have bits, and those bits are made up of little transistors, and those transistors can be on or off, and we map those ons and offs to zeros and ones, and that's binary.
Okay.
With a quantum bit, on the other hand, the bits can be in a superposition state where they can be 1 and 0 at the same time. And they can be what's called entangled together. So if we had a pair of qubits here and we entangled them together, you could go off to the other side of the universe, and something I do here on my qubit would instantaneously affect yours. Quantum particles have these wave-like and particle-like natures, and we can use the wave-like nature of quantum particles and interfere them together. And that allows us to program in a really different way. So the two of us are sitting at this big boardroom table.
Yep.
And so imagine now if this weren't just a flat table, but this were a flat pool of water, and I were to drop a rock in. What's going to happen?
Okay, you're going to get the ripples that kind of go out from the rock.
So if we drop 2 rocks in, what happens?
You're going to get 2 sets of ripples, and probably some of them will overlap in different directions, and one ripple will affect the other ripples too in different ways.
Exactly. So we can use the interference patterns of these 2 particles. We can interfere the waves of these 2 particles, and in some cases they will constructively interfere, and that wave will get bigger.
Okay.
Or they will destructively interfere, and the wave will go away. And so that's how we program these quantum computers, with these properties of interference and entanglement that allows us to compute in really different ways.
Interesting. So as you start programming that, how do you even start programming it? Because again, I'm an IT pro, so I think programming, like PowerShell and C# and Java. How do you get into programming these quantum computers? How do you take advantage of that and write code for quantum computing?
Yeah, well, the good news is the quantum algebra and how these systems interact, it's all linear algebra.
Okay.
The math is pretty straightforward for those who have had linear algebra. And the great thing is that we've made at Microsoft a really accessible set of tools for developers to get started programming quantum computers. So a couple years ago, we announced it at Ignite, actually 2 years ago.
I remember seeing that, like the computer, they brought one out on stage, actually.
That's right. So we announced that we were going to be launching Q#, which is a quantum native programming language within the Microsoft Quantum Development Kit. And so we've got Q#. It should be familiar to a lot of your audience.
Okay.
Folks who are familiar with C# and F#, it should be a really familiar language. We've launched the Quantum Development Kit. So it's really a high-level modern programming language. And so it's got all of the functionality and productivity tools that you would expect from a modern language.
Okay.
And it ships with a rich set of documentation, tutorials, sample code, and simulation environment. And it's really designed for programmers, not for physicists who are deep in the lab, but for programmers and domain experts. And we've launched a few things to make it really accessible. One is we launched the Quantum Katas. So these are a set of learning exercises, tutorials, and they start out, they're modeled after, inspired by karate exercises, where you start out with a simple exercise and it gets increasingly more complex as you work through the exercises. So those are available. And we've created this simulation environment so you can test out your code. It's all open source. It's up on GitHub, and we've had a tremendous amount of contributions to the community. We have over 200,000 downloads of this kit. It's really designed not to be intimidating, but to be really accessible. In the spring, we also launched just a web, no download programming environment. So we've done the integration with Python. And so you can go to our website and to our tools and start programming just in the browser using the Python integration. So in a Jupyter notebook, you can go ahead and get started programming a quantum computer.
As IT professionals in the cloud era, sometimes it feels like we don't speak the same language as the rest of the organization. So when stakeholders from finance or other departments start asking about a specific project or team's Azure costs, they don't always realize how much work is involved in obtaining that information, sifting through cluttered CSVs and a complex mess of metadata in order to manually create custom views and reports. It's a real headache. On top of helping you understand and reduce your organization's overall Azure spend, ShareGate Overcast lets you group resources into meaningful cost hubs and map them to real-world business scenarios. This way, you can track costs in the way that makes most sense with your corporate structure, whether it's by product, business unit, team, or otherwise. It's a flexible, intuitive, and business-friendly way of tracking Azure infrastructure costs, and it's only available in ShareGate Overcast. Find out more on sharegate.com/ITPro.
Very cool. So as you're programming these quantum computers, you said you spend a lot of time talking to businesses. What types of problems would you solve with this? Because you think quantum computer and the speed, it's like decrypt anything right away. Obviously, you don't want to go say, hey, general public, here's how you can go start programming to decrypt anything that's encrypted using these quantum computers. But with the businesses, I know in the keynote this morning, they talked about some MRI, I think it was MRI results, making those faster, more predictable. What types of areas are really starting to leverage quantum computing, and where are you starting to see this show up across different businesses, and kind of in what ways?
If it's okay with you, I might tackle the crypto issue first.
Okay.
So that's top of mind to a lot of IT pros that have really grokked what's going to happen with quantum. And so it is really important. And Shor's algorithm Peter Shor came up with that in the 90s, and the power of that algorithm, that generated a lot of excitement and energy and investment in quantum because it'll break modern public key cryptography. And so we see that as we take that very seriously at Microsoft, and ensuring that not only customers in Azure but customers around the world are protected from quantum attacks when quantum computers become available at scale to do those types of things. So it requires a significant number of error-corrected qubits. We can get into what that means. So these are going to be relatively large systems. But if you think that might become possible within the next decade, it's time for IT pros to have that on their radar today. And so Microsoft is leading the field in what's called post-quantum cryptography. So these are cryptographic protocols that are safe from not only quantum attacks, but also classical attacks. And so we've been participating in the NIST protocol, so run by the National Institute of Standards and Technology. And they're running this protocol to assess post-quantum crypto algorithms. So we have 4 submissions to that. We've progressed to round 2. We've been doing this all in the open source. It's an open collaboration between us and other public and private institutions. We have academic institutions there. And so those protocols are available now. And the thing for IT pros is to make sure that they have cryptographic agility so they can move to a new crypto standard when that becomes available, but also to start testing these protocols in their systems now. So
got it. So what do those protocols look like? I mean, now it's like you have the 248-bit or you have 496-bit encryption. Is it just adding more bits, or is it an entirely different mindset when it comes to cryptography in that post-quantum world?
These are pretty different protocols, and I'd refer you to Brian Lamakia's team. So you can check them out for yourself, but they behave a little bit differently. Some of them take longer compute processing time or larger key sizes. So that's why it's really important to start testing these systems now. And, kind of going back to your question about, what are the application areas? Mm-hmm. So that's not an area where, we're not, pursuing Shor's algorithm, but making sure our customers are safe and that we live in an environment where people's data is secure. That's super important to us. That's why we've been doing this all in the open source.
Yep.
But the application areas where we're really excited about the potential for quantum are in 4 key areas. So the first 2 are in simulating physical systems that are inherently quantum in nature. And so the way that nature works, the way that our bodies work, we're quantum mechanical systems. So understanding really hard computational chemistry problems where, classical systems don't have the accuracy that we need to really have predictive R&D. So today, the way that works is if you can't get, what happens in areas where you run out of compute power? What do you do?
Right. You have to go buy more or build bigger data centers or faster CPUs or more memory or whatever technical equipment you need to kind of scale out that environment or scale it up.
Yeah, and what happens when that runs out?
You have a problem.
Yeah,
or you go buy more or more. And eventually there's a limit. I mean, we say the cloud is unlimited, but let's face it, it's still just a bunch of hardware.
There's problems in chemistry and materials that would take us, with using all of the compute power that we have on the planet longer than the lifetime of the universe. And so what we do when we hit those limits is then we simplify the model. We make assumptions. But sometimes those simplification assumptions then don't reflect reality well enough. And so, there's an example that we've done a bunch of research into in the field of catalysis. So the way that nature fixes nitrogen into the soil, farmers plant beans. Mm-hmm. That bean plants have a bacteria that grows in the roots of the bean plant, and that bacteria produces a catalyst called nitrogenase that can fix nitrogen into the soil. But understanding the basic chemical properties of that molecule would take us longer than the lifetime of the universe on conventional compute.
Interesting.
But that's a problem that a quantum computer can natively inhabit the quantum state of that molecule, and we can start to do simulations of that molecule to understand it in maybe days.
Wow. That's fascinating.
Yeah. And then you compare that with, traditional ways or conventional ways, I should say, because the traditional ways to plant beans, conventional ways of adding, say, nitrogen into the soil done with artificial fertilizers. And that Haber-Bosch process to produce those artificial fertilizers, that consumes 3% of the world's natural gas.
Wow.
And so if we can, change the way that we do R&D in that space, could we have something that's more sustainable?
Okay.
So that's one application area. So that's simulating a physical compound that's natively quantum mechanical.
Right.
The next one is materials science. So same kind of problem, larger scale systems.
Okay.
So, could you use a quantum model to design a room temperature superconductor? So something that where electrons travel near the speed of light with no losses in the material.
So
we lose 3%, 3% was the last one. 15% of electricity generated in our grids is lost just due to the losses in the materials.
Okay.
So those are the first 2, chemistry and materials, so simulating physical systems that are quantum in nature. The next one is solving hard optimization problems. So think really combinatorial optimization problems where you have, hundreds, thousands of variables. These could be highly interacting with each other. So think traffic optimization, job scheduling, route planning, these also go into the materials side, designing new materials, verification and validation. These problems show up over and over again.
Got it. Creating your schedule for Ignite.
Yeah,
Can
exactly.
It help you with that? Figuring out which sessions to go to and how to fit as much in as possible.
Well, you want to fit as much in as possible, and you've got constraints in the system. You can only be in one place at a time. Yep. You have sessions that are conflicting with each other, sessions that are adjacent but have a long walk between them. Figuring out the optimal schedule, not just for you, but all the participants at Ignite, with the constraints of room size and routes between them.
How about lines at Disney World? Can it help with the lines and the people optimization with Disney?
Highly relevant for being in Florida, yes, in Orlando. So these problems are really exciting for quantum computers, and the way that quantum helps with this is, finding that optimization is really a problem that scales. You have this exponentially vast search space when you have so many variables interacting with each other. And so this is another case where, we run out of compute power to do that in a reasonable time frame. If you're doing a traffic simulation and it takes you hours, that's not a relevant time scale for the problem at hand.
Right.
And so with quantum computers, you have some really rugged search landscapes. So not kind of rolling hills, but say the Swiss Alps. Okay. And you can imagine you've tasked a hiker to go find the valley floor, and they start out somewhere and they walk down. They walk downhill, but they could be in a high up subalpine valley where it's very expensive for them to reach the true valley floor if they have to cross over a high mountain peak to get there. Okay. And so with traditional classical optimization protocols, where you have this really rugged search landscape, they tend to get stuck in what's called the local optima. They don't find the true solution. Got it. But when we search that space with quantum particles, they can tunnel out and get to a much better solution much more quickly. And what's exciting about that is just the insight of understanding how a quantum computer would solve this problem has led to breakthroughs where we can emulate those quantum effects in Azure today.
Everyone on your team is unique. So is SkillMeUp.com. Only SkillMeUp provides the bridge from fundamentals to certification paths to advanced skills to accelerate digital transformation with one subscription and 5 ways to learn. Start your free pilot today and supercharge your IT and Microsoft Azure skills by visiting skillmeup.com/pilot or click the link in the show notes below.
Got it. Which kind of leads us to another announcement. You guys announced today it's Azure Quantum.
Absolutely.
Right? I think was the actual name of the service that you guys announced today, where you're working towards kind of a cloud-based quantum access to quantum type resources. This obviously today isn't access to a bunch of quantum computers. I don't think it's more doing some of that computational work on the cloud. But what is Azure Quantum, and kind of where do you see that going over the next few years?
Yeah, so it's actually both. It's access to quantum hardware and classical solutions that use this quantum intuition in Azure. So what Azure Quantum is, it's a full end-to-end quantum compute stack, and it's really building on innovations that we've been leading across the entire stack. So it's not quantum is going to come about not just from innovations on quantum hardware, but every layer of that compute stack. We do this in a cryogenic environment. It requires a really different approach. So Azure Quantum is really bringing the most diverse set of solutions, software, and hardware to people and organizations around the world. It builds on the work that we've been driving in the applications and algorithms, like the areas that we just talked about. As Satya this morning talked about work that we've been doing with Case Western Reserve University, where we're using these quantum-inspired approaches running in Azure today. And we optimize for speed of an MRI scan. We can increase the speed by a factor of 3, which has huge impacts for, not only healthcare costs and accessibility to that type of diagnostic imaging, but also patient comfort and patient outcomes. When the researchers at Case Western Reserve share stories about, children with brain tumors coming in who have to be sedated to go into the machine. And if we can accelerate those scans and make them much shorter, that can decrease anxiety. You have, patients who aren't able to stay still for the whole time of the scan. So it can improve the accuracy by decreasing the scan time just to keep them still long enough. When we optimize for precision of the scan, we've seen, improvements of up to 30% in the precision of the scan. So that really, changes the types of diseases they're able to detect and improve the accuracy of those diagnoses. So that's, building on that application layer. We have a lot of work we talked about earlier on the software and the programming side, rolling on Q# and the QDK. We have more than 200,000 downloads now of the QDK from developers around the world. And then breakthroughs that we've had on the hardware side. So if you've gone to our booth, we have an example of a chip that we're using for cryogenic control of the quantum hardware. And so this will allow us to control up to 50,000 qubits in this cryogenic environment with just 3 wires. So we've been building this end-to-end system. And what we're announcing with Azure Quantum today is really bringing this diverse set of innovations across the stack together with hardware partners. So we announced that Honeywell, IonQ, and QCI will be bringing quantum hardware to Azure to make that accessible to people around the world.
Okay.
And also 1QBit, who's bringing software and algorithm solutions.
Got it. Very cool. So what are some other... Did we talk about the fourth area?
We didn't talk about the fourth area.
We didn't talk about the fourth area. You mentioned Azure Compute, and you got me all distracted with the Azure Compute announcements. So we had the 3 areas. We'll go back to that. Look at the fourth area. It was the physical world, the quantum stuff there. It was optimization. It was... The middle one was... something else.
We had 2 in the physical world.
Yes, 2 in the physical,
chemistry
that's right.
and materials. Yep. And we talked about optimization. And the fourth one that we're excited about is machine learning. So we've seen from our research, we have a large research group that does research into quantum algorithms. And we've seen that for large quantum models, the quantum systems can train exponentially faster than the classical systems. And so we're really excited to see what happens when, smaller quantum systems come online and when we start to see those advantages.
So just the pure capabilities of the quantum then, when you get into the machine learning, just help the machine to learn faster, better, probably take more, going back to kind of like the optimization, it's able to compute more inputs or more information and just take that much more information to help with the machine learning?
Yeah, we think it'll, give models that reproduce reality better. And then we have models that maybe don't train, don't converge when we're training them with classical systems. It's sort of similar to that optimization space. If you've got something which looks, highly convex or looks like rolling hills, it's easy for classical systems to find the best answer. Yeah. We think that optimization is likely to help with machine learning problems as well.
Everyone is always looking to save time in their day, just like moving to the cloud can save you from the mundane tasks of patching, updating, and maintaining servers. SaneBox can save you from the mundane and time-consuming task of managing your email. SaneBox works with your existing email configuration to make your mailbox awesome. It may be using Sane Black Hole to avoid mailing and cold sales emails, or Sane Reminders to automatically remind you when you need to follow up on an email. You can even snooze an email, just like that pesky alarm clock in the morning, to defer or to de-emphasize an email that doesn't need your immediate attention. So what are you waiting for? There's nothing to install, nothing to learn. Just go to sanebox.com/allthings. That's sanebox.com/allthings to get 2 weeks free and a $25 credit.
Very cool. So anything else around quantum? Again, because I'm learning as we're going as well. Anything else we haven't talked about around quantum that either is like really fascinating to you or everybody really needs to go check out, know right away? Yeah. Anything else in that space that you want to talk about and educate me and our listeners about?
Quantum truly is going to be groundbreaking, and it already is groundbreaking today. We've got this system where, because we're computing with these really different building blocks, every time you add a bit to the quantum system, you double the compute power of that machine. And so we know,
interesting.
It's these, today we know about these niche areas.
Yep.
And so, we talked about these four areas. Now that we got all 4, that's pretty niche relative to what you can do in all of Azure. Right. And, what we're really excited about is bringing this open system to the market with Azure Quantum and really opening it up for us to realize not only the promise of those 4 areas, because on the one hand, it's only those 4 areas, but those, have the potential to be totally industry changing across every industry. I mentioned talking to customers. Talk to customers every day, and I've yet to talk to a customer that doesn't have, some hard optimization problem or materials problem in their organization. And the work that we're doing with customers today is starting to change the way that they think about problems. How much time are you and your listeners thinking about their unsolvable problems?
Oh, I'm sure it's tons. Like, I'm sitting here thinking about all these unsolvable problems that I'm like, oh, I wonder if I could help with this. I mean, we're in Florida. I was thinking about hurricanes, too. Like, we had a couple hurricanes go through earlier this year, and I watch the news. I try to avoid the news sites and actually go to the sites that look at the data about how the weather around the world affects a hurricane. And I'm sitting here thinking, I wonder how quantum could affect that and predicting these hurricane paths and what they're going to do, because it changes. Like, you see a mile an hour or two change, and the hurricane changes where it's going to go by like 150 miles or 200 miles. And all these things, it's just like I feel like the possibilities are endless.
The possibilities truly are endless for quantum. And we know these as, a small set of quantum algorithms. And to realize the potential of those ones that we already know about is going to take this diverse community. It's not, we have a really diverse set of experts working on building these quantum systems, from mathematicians to computer scientists and chip designers and physicists and electrical engineers. The list goes on and on. Where the magic really happens with this work is when we pair our team of algorithms experts with domain experts in these different areas. Because we understand deeply how the quantum computer will solve problems. And, for example, the team at Case Western Reserve understands how MRIs work. And so pairing those 2 teams together, we're able to really have rapid innovation and rapid iterations in a field that sees 10% improvements come around once in a decade. We have 300% improvement in just our teams working together for a handful of months.
Wow.
And so that's, really, it's really going to change. And then, as more people have access to these systems and the tools, across disciplines, we're going to discover new quantum algorithms. And so, I think we're going to dramatically expand from these 4 areas, or really increase the richness and diversity within those 4 areas.
For sure. So with Azure Quantum, how do you get involved if this is something you really want to go start learning about, try out, because it's still in preview, if I remember right, and it's not just go spin up a preview. I think you had to apply for the preview, and I'm assuming there's some process you have to go through. If somebody listening has some problems, wants to get involved with Azure Quantum, what's that process? How do they go through kind of getting more involved with this or leveraging that preview of Azure Quantum?
So there are a few ways to get involved. I like the question. So today, this is a pre-announce. Azure Quantum is going to become available in private preview in the coming months.
Okay.
And so you can go to our website to learn more, sign up to express interest in joining the private preview. We're going to be rolling that out to our early access customers and to the participants in the Microsoft Quantum Network. Programmers can also get started today using Q# and the Quantum Development Kit. So as we mentioned, those are all open source tools. They're available through GitHub. You can also go to the website and do the no download, get started. You can start teleporting quantum bits on your laptop today. I promise you, it's super fun.
All right.
And then the last area that I want to talk about is the Microsoft Quantum Network. And so this is really an interdisciplinary, diverse set of people and organizations that we've been working together with to advance the state of quantum algorithms. So if you are an enterprise customer, we have a program called the Quantum Early Access Program that pairs enterprise customers and partners together with our team of algorithms developers. And we go really understand what are the application areas within different organizations that are going to transform the way that they work. And so Satya shared a few of the organizations that are in this program with us today. So Case Western Reserve University is a great example of what that type of partnership looks like. We're also working with the Dubai Electricity and Water Authority, optimizing electrical grids. We have a partnership with Willis Towers Watson, a leading financial services and brokerage company. And so, we're working with customers in that way. We also have a really rich startup program. We've got 18 startups partners with us. And so there's a lot of ways to get involved in the Microsoft Quantum Network today.
Very cool. And we'll go get some links, put a bunch of links in the show notes so people can click on it, go check out the website, the services, go look at the GitHub repositories we talked about and all of that. So thanks, Julie. I really appreciate it. It was interesting.
Thank you as well.
A lot.
It's a fun conversation.
If you enjoyed the podcast, go leave us a 5-star rating in iTunes. It helps to get the word out so more IT pros can learn about Office 365 and Azure. If you have any questions you want us to address on the show or feedback about the show, feel free to reach out via our website, Twitter, or Facebook. Thanks again for listening and have a great day.